opening up. That's good. Yes, it was. Here we go. And we should be live now. So I hope it's the correct event because I planned the one for August already. And it is, and I'm not muted. Splendid. So, hi there, folks, and welcome to this month's talk for the virtual Kotlin user group. And it is bang on 7 p.m. Look at that. With me is the incredible Marcin. Hi, how are you doing?
Hello, I'm great. And you?
Not too bad at all. I'm not melting today, so I really like this. So it's like consumable temperature. Yeah, so we do have 13 people already. So I think let's get this party started. As always, just some maintenance at the beginning. If you haven't done yet, click this subscribe button and the bell to get the notifications. If you like us, hit this thumbs up. If you don't like us, tell either of us or both of us, and don't click the thumbs down button. And if you have any questions, please leave them in the chat. I will monitor the chat and collect the questions, and we'll definitely make sure these questions make it to Marcin. I will shut up now because it's your show, Marcin. Enjoy. Thanks.
Thank you. So I would like to talk to you about what I think is the most essential feature. I'm even sure it is the most essential feature of Kotlin Coroutines, because everything else based on that. And I believe that if you build a proper understanding of how a suspension works, everything else gets much easier. So today I'm going to talk a little bit about suspension. Suspension is everywhere in Kotlin Coroutines. You surely have seen suspending functions. The core idea of suspension is that you can stop function, stop coroutine at any point, and when you stop it, you have this small object that is called a continuation, and you can use it to resume this function from where you stopped at any point you want. So you can, it's like a save of a game, you know, you play a game, and at any point you can just save it. You can go do something else. Your computer can go do something else. And at any point of the time, you can go back and resume your save and start from where you stopped in the game. This is the most essential part of Kotlin Coroutines. We will be discussing about it today. So here you can see it used in practice. So here we some get news from API. The essential thing is that this whole code runs, this code here runs on the main thread. So if we would need to block this thread, we would make our whole application Android freeze, and we will see a dialog that application is not responding, and our application would crash. But thanks to the fact that we are actually suspending, not blocking, we are just we can just suspend for the time when we are waiting for the data. The main thread can go do other things, handle some fancy animations of our application, or do something else. And once the data are there, we grab the main thread again, and we resume from the point where we finished. So this is the suspension capability. Before I start with the essence of how suspension works for the use point of view, because there is also a part, I also have a presentation about how does it work under the hood, and it will be described in the book I will mention in a moment as well. But today I'm going to explore suspension from the use point of view. So just before we start, I just want to say that this is a small part of my workshop, Kotlin Coroutines, that you can find on KT Academy. It's a very popular workshop. It's, I believe, really well prepared. And I think it's one of the best workshops of mine. I am always conducting it myself. On the workshop, we have a conversation here with a group, and what's really nice, I really enjoy it every time I do that. Although here we have a delay, so I will not ask you questions. I will not have so much conversations. I will just give you answers immediately. If you have some questions, please send them on chat and I will answer them later. Also, this content I described, I made an article out of it. The article is not yet published, but you can find here a link. The link to this presentation should be on the description of the video. Here is a link of the article. So if you want to follow or if you want to read it later, you can use this link and run all the examples I will be showing to you using the Kotlin Playground. And finally, it is also a part of a book I'm working on, Kotlin Coroutines Deep Dive. I hope to finish a minimal version in a month from now on, and then it will be ready for the first early adopters, early readers. The whole book will be probably finished by the end of this year. So I'm currently working intensively on that, on coroutines and on exploring those topics. So without further ado, let's talk about suspension. Our starting point will be a suspending function. This will be called. Will be running on a coroutine. We are not talking about other parts of coroutines yet. So I wanted to use as minimal amount of features as possible. So suspending function is like a normal function that can be suspended. So if I run it, I can run it like a normal main function. It shows before and after, but the thing that it can do when what normal suspending function cannot is that it can be suspended. The most basic way to suspend a coroutine is by using suspend coroutine function. So here I would ask you the first question: what do you think will happen if I do that? You can stop and think about it. The answer is that at this point we are suspending, so we are kind of stopping our game, but we never resume it. So we stopped at this point, and this is where we kind of finished. Since our program never finished, we never reached the end, our program is still running. It is still suspended. And the program cannot finish because I suspended the coroutine in the middle. And you can see after is not printed. You can see here only before. Okay, so this is the way how we can stop our coroutine. How can we resume it? So for that, we need something that I described as a save of our game. It is called a continuation of type continuation, and that is provided to this lambda expression as an argument. So inside this lambda expression, we have the continuation that we can use to restore our game. Before I talk about restoring it, a word about this lambda expression. So counterintuitively, this lambda expression is called before the suspension. So this is the last thing that happens before suspension happens. Yeah. So if I placed here some text, you will see that it is printed before the suspension. So we have both before and before two printed. Yeah, so this is what happens before we suspend. That's our last bastion. So here we can do something with the continuation. The most rudimentary thing to do is to use it to resume. So what I do in here does not make much sense, but shows us the point. What we did is that we suspended the coroutine and we immediately resumed it. So by calling continuation.resume, we are resuming our continuation, and starting from where we finished and reaching the after and finishing the program. So you can see resuming works fine. Okay, that does not make so much sense, but I just wanted to show you that now we can postpone the process of resuming into some other place. For instance, a very trivial way could be to make some thread, make it sleep for a second. This is a terrible implementation. We are wasting a thread for a second just to postpone something. I will show you a better way in a moment, but just to start with a simple example, I make a thread, I make it sleep for a second, and just after the second I resume. So let's see what happens right now. You can see we have before 1 second delay, and then we have after. Yeah, so I can postpone resuming for later. Okay, let's try to push it further. I can actually define a function. Maybe I will extract a function like that. So not a continuation. Okay, so fun invoke after second. Not a beautiful function, but shows the point. I will have my operation, and inside I will just do most of that in here. I will just call operation, and so invoke after second and resume. That will work the same way. Yeah, so we have before, after 1 second, we have after. Okay, so you can see where is the continuation when we are waiting. So the continuation is captured by this lambda expression, and it is waiting there. Hope you start building a picture. Let's push it further. So maybe even we'll pass the continuation in here. So instead of operation, we'll have a continuation. And instead of invoke after second, we'll make resume after second. Okay, so now what we do is that we are directly pushing continuation object into this function, and this function calls it after a second. So I hope you start building a picture that continuation can be, pushed forward, moved here and there, can be stored somewhere. In fact, it can even be formally, it can even be serialized somewhere, and after some time deserialized and resumed, just like that. As far as I know, there is no library that is supporting that, but according to the documentation, this is possible. Why? Because continuation holds whole state yet to be, whole state needed to resume from this point, just like a save of a game holds everything that needs to be saved in a save to resume, so the state of the game, everything that changes in the game. The same with continuation, it stores the state of a function, so all the local variables, it calls the places where we finished in different functions, and it can be used to resume our code, our coroutine from that point. Okay, so that's, as I said, that's not a very practical thing to delay for a moment. A better way would be to kind of set up an alarm clock. Yeah, so we just suspend and we say, hey, after set amount of time, wake me up. For that, we could use this executor from Java library. So executor, new single thread executor that we can use to schedule to wake up after some time. It still needs, a thread, but it's only one thread for all coroutines. So that's much better. And so right now I can just do schedule after 1 second continuation dot resume. Okay. So the behavior should be exactly the same. Yeah, so we have before 1 second delay and after. So so this works, but notice that here we are not, having a dedicated thread. Yeah, so it's like we are for 1 second we are like going to sleep and nothing is running, and after 1 second the executor wakes up and says, hey, resume from this point. And this is what happens. This body could be extracted as well. How could we name it? Maybe delay. And this delay function can be parameterized. So we could name it time millis. Okay. And could be public. So now let's just clean it up a little bit. I'm just changing formatting. And this is exactly how delay used to be implemented in the Kotlin Coroutines library. Right now it has some extra layers for testing, for fake time for unit testing, for multi-platform capabilities. But basically, this is how delay works, and this is exactly how it used to be implemented. So you see, it's not blocking thread, it is suspending a coroutine, and it is scheduling to resume this coroutine after set amount of time. So that is a nice thing to know about. Okay, so that's one thing. I am moving to the next chapter, but is there any question on the way?
There's nothing at the moment, so it's rather quiet on the chat.
Great. Okay, so if you take a look at the types in here, you might notice that here, when we call this suspend coroutine, we need to provide some type. I provided a unit in here. I also provided a unit as an object path to resume. Is it coincidence? I don't think so. I can also specify continuation type explicitly, and you see unit as well. The same with the return type in here, you can see it explicitly, that's unit as well. No coincidence at all. If I would place a string in here, then I will need to place some string in here as well. I would need to have continuation with string in here, and I would need to have string in here. Why so? It is because we can resume with some value. In this case, we resume with some text one. Previously, we resumed with some unit. We can resume with some value. And what happens with this value is that this value will be returned by suspend coroutine. I know it's confusing for many of you because it's like that. We suspend coroutine. We call suspend coroutine function. But before coroutine is suspended, we call this lambda expression. Yeah. Then in this lambda expression, we resume continuation. And when we resume continuation, we get back to where we finished. Where we finished at the suspension point. So suspend coroutine. This was the last thing that happens. So what's the next thing after this one? The value that is returned. Yeah. So when we put something inside the resume, it's like it is jumping out of the suspend coroutine. That's a very important mechanism. So here we can see it in practice. We'll here print text one. I can already show it to you. In a similar way, we could print some number. So maybe too many types in here. So I could have some number in here. And I could have some Boolean in here. And any other type as well. So true in here. So just to make it clear, we have before, then we have text1, then we have 42, then we have true, then we have after. So in every single case, whatever we placed inside resume is returned out of this suspend coroutine. It's a very important mechanism because it can be used to pass something important that we were waiting for. You remember our first example. We were asking API for data and we were resumed with that data. Yeah? So when we got back to the coroutine, we wanted to have those data we've been waiting for. And this mechanism is used quite often, just like let's make an easier introduction to that. So here we will have a user that will print in here. We'll expect a user. Continuation will also expect a user, and here we'll have a user with some name. Just to make it clear, user will be returned out of this suspension. So this exactly the same mechanism was and is used to wrap over callback functions. Like here we have a callback function that is used to request a user from API. We would prefer to have suspending function. We can have it easily if we wrap it with this suspend coroutine. So inside suspend coroutine, what we need to do is to request user. So the callback function, once it has the user, it calls this lambda expression with the user. So what should we do? We should resume our continuation with a user. Does it work? Let's take a look. Before, 1 second, we have our user returned by this callback function. So everything works. So this whole body, this is what can be extracted into a suspending function. Yeah. So request user. That's not well refactored, not well extracted. That's better. Maybe I will make type explicit. The continuation type does not need to be explicit, and here a small reorganization. That's nice. Okay, so this is how our very simple suspending function request user might look like. It just suspends coroutine, but before it suspends it, it calls request user and says, hey, once you have those data, once you have this user, called continuation.resume. So wake me up when you have the data. And this works just as before. That works perfectly fine. And this is how we used to wrap over suspending functions to have over callback functions to have suspending functions. Currently, it is done differently. I will just say right now that we use suspend cancelable coroutine. I will tell a few other words about it a little bit later. But before we can talk about it, I would like to talk a little bit about exceptions here. Because sometimes API give us a nice data, sometimes API give us an exception. And what should happen in such a case? So we also have it considered in our suspending functions. So let's suspend coroutine again. It can be suspended with user, doesn't really matter. User, and we can have a user in here as well, just for the sake of reference. But what if we have an exception? If we have an exception and we want to signalize about it, we have this other function, resume with exception. Resume with exception. By the way, currently the interface continuation has only function resume with that expects a result. Those two are extension functions. But I find resume and resume with exception more convenient to use. And the result is exactly the same. They just use resume with under the hood. So you can use them freely. Okay, so I will resume with exception, and I will put some exception. So what happens if I resume with exception is that this exception will be thrown out of the place of suspension. Yeah, you can see. You can see. Does it show it this way? It actually shows even this place, but it will be thrown out of the place of suspension. You can catch it. You can do try catch my exception. So I'm not catching anything. I'm just catching this concrete exception and print ln caught. So let's see it. Bam, we got caught in the middle. So you can see that when we call resume with if you call resume out of this place, you will have returned a value. If you called resume with exception out of this place, you will have an exception thrown. So it's more or less the same as having here throw my exception. Yeah, that's how it is going to work. And this mechanism is used in such functions as well when we wrap over callback functions to make suspending functions. In here, I will call my other function I prepared, request user with exception. Maybe the naming should be rather with exception handler or something, but I just wanted to distinguish those two functions. So first, on success, we will resume with the data. On error, we will maybe throwable. We will resume with exception. And I can tell you that this function is having a random result. It's either throwing an exception, it's either calling on error or on success. So we can call it a few times to see. Maybe I will also try catch to see what's caught. Catch throwable. And T. Okay, so let's see if we are lucky. What do we have? We have API exception. So we got an exception right now. Let's see another one. Okay, this time we have data. We are very, very lucky today. So this is a very, very simple way to wrap over the callback function to have a suspending function. I wanted to add a word about the suspend cancelable coroutine. Suspend cancelable coroutine additionally provides a better support for cancellation. One part of that is that you can set up a listener on cancellation that we often use to cancel the call. Many libraries that we use support canceling the call. That's useful because we are not waiting for this call. So if we cancel that, we are wasting less resources that are not needed anymore. Also, you can cancel with different exceptions conditionally. So I resume with different exceptions conditionally. So you can see this is one of my way to handle the retrofit calls. Yeah, so I here resume if everything is fine. If the body is empty and it should not be empty, I throw exception, respond with empty body. If there is some network exception, I also construct and throw it. If there is some failure, I also construct it and resume with this exception. Don't do that at home. Retrofit, just like many other libraries, have a proper support for coroutines. but I just wanted to show you how we used to do that, how we needed to do that when such a support wasn't yet ready. Okay, the last thing that I found quite problematic for many people is that we are suspending a coroutine, not a function. So if we do, let's say that you have a, function. How can we name it? Okay, let's not suggest any behavior, so I will name it very badly, AAA. Okay, when I do suspend coroutine, I can get back to unit in here and start a continuation here. Okay. This continuation might be stored somewhere. Normally, you know, there are better and worse way of storing that. What I'm going to do is rather a bad way, because it has a huge potential for memory leaks. So don't do that. But just for the sake of showing you something. Don't do that. Okay, I will do that anyway. So let's make it A. So here I suspended a coroutine, but before doing that, I stored the continuation in some variable. Yeah. So I often ask people what would happen if I would do here continuation.resume that unit. And too long delay for us to discuss it, but the often answer is that I will see before and after. Of course, I will not see before and after. When I suspending in here, I am not suspending a function. I'm not suspending this. I am suspending a coroutine. So I'm suspending that and even more, you know, everything outside of that until the coroutine builder. So I am suspending a coroutine. So doing something like that, resuming later in this coroutine is like, you know, resuming a game later in the game, you know, like if you save a game, but you know, to resume it, you would need to be later in this game. I mean, that makes no sense, obviously. So remember, when you suspend, you not suspend a function, you suspend the coroutine. So everything up to the coroutine builder, something I will be talking about, I hope, in another presentation. So how can it be improved? The trivial way is that it could be resumed after some time from another thread. So we could do something like that, and this would work. This would work perfectly fine, no matter how long the continuation stays there. As I told you, the continuation is just, you know, object holding the hold state needed to resume at any point of time. We could also use other coroutines for that, but to not make this picture too complicated, I decided to leave at this point. I hope that after this lecture, you have some deeper understanding, or maybe even very deep understanding of how suspension works from the use point of view. What do we suspend? I hope that you also understand how delay works and how can you wrap yourself a callback function with a suspending function. I find this knowledge pretty useful, less nowadays when we have good libraries for that, but it used to be the most basic knowledge for Kotlin Coroutines users. And I hope it will help you on your way of learning Kotlin Coroutines. I will be publishing articles that are part of the book on the KT Academy articles section. You can find link in here. Also, I'm currently publishing items from Effective Kotlin, reviewed and refreshed items from effective Kotlin, adjusted to whatever changed in the language. I also remind you that this is part of my Kotlin Coroutines workshop. KT Academy is not only about Kotlin anymore, so you can find there many other workshops by many other teachers as well, including refactorings to patterns or refactoring to clean code. Wodek Krakowski is making really great workshops, or Angular, or modern JavaScript or TypeScript. Even testing, I have a contact with people who introduced A/B testing in Allegro, and they are really, really good in that. Okay, so that's everything from my side. Thank you for your attention. And this is how suspension works. Do we have any questions on the line?
We sure do. Let's go them through chronologically. Simon Clement asks, executor opens a new thread, as I understand.
Yes, so as executor does use a thread to, operate, but it's one thread. As far as I know, it's one thread for them all. So do we have it here? No. Yeah, that apparently there must be some thread to to operate, but the point is that we are not blocking the thread we are running on. There is like one dedicated thread in the executor that is handling all the coroutines, and that's it. And probably it gets inactive if it's not needed. I'm not so sure about that.
All right, then there is a longer question from, I hope I don't screw this up, Shervin Shorai. I have one question about continuation concept. What is its relation to method signature when Kotlin is converted into bytecode? I'm trying to understand why didn't we have this in Java?
Oh my, Java is working on that because there are two approaches how it can be done. The holding a state of a single function is easy. Yeah, that's trivial. Holding a state of a whole stack trace that is not a single function but many functions. One function calls another, calls another, calls another, calls another, and you need to keep a state of them all. That is a bit more difficult. On the workshop, I explain it in detail. Also, I had a presentation that maybe is not so much detail, but where I also tried to explain it. But the simple explanation is that coroutine, the continuation looks like an onion. So it uses a decorator pattern. Every single suspending function has its own continuation that is wrapping over the previous continuation. And each of these functions is having a state of the current function and a reference to the outer function, to the continuation of the outer function. So when you call these suspending functions, that's easy. You are just wrapping over wrapping over wrapping over wrapping. It is more complicated if you need to resume, because when you need to resume, you need to do the opposite. So you need to go from inside to outside. So what happens is that you start from the closest continuation and you run it until it ends. So it's kind of, you run it until the either function ends or another suspension. Yeah. Once it's done, it calls another continuation from the points when the function stopped and runs from this point. We can jump at the middle of the function because there is kind of state machine inside. Maybe I got into too complicated stuff. It would be easier with slides, but that's another 30-minute talk. And so we are kind of reversing. We are kind of pretending to make, like, we are making a fake stack, call stack. Yeah, we are calling one continuation, like first we call child continuation, then parent continuation, then its parent continuation, and this is how we reproduce the stack trace of it all. that's how it basically works. This is how it that was the best way to implement it that Kotlin had. On the other hand, Java has a different tools, because Java can control the actual stack trace. It can control the virtual machine. So instead of making these objects pretending to be a stack trace, it can actually make some kind of save of an actual stack trace, and so it can make the coroutines that will be more optimized and probably more optimized basically. And this is what they are working on. There is this project of implementing Java coroutines, but this is a really, really hard task. So we will be probably waiting for that. As far as I know, Kotlin is ready to jump to use their implementation once it's ready. So if it will be ready for Java, I'm pretty sure soon it will be also benefiting Kotlin developers running on the JVM.
Yes, similar to what we saw with a couple of features Scala made really popular, and then out of the sudden Java or JVM provided these features directly. We have a couple of more questions. Sergey, and I don't even try his last name, sorry, Sergey. Can we handle it with Kotlin.result? And this was on the topic of resume with exception.
Yes, we can. I mean, I understand you mean resume with and produce.
Do you think so? Yeah, it was around the time you were talking about this. Yeah.
Yes, why not? Result, success, user. I just like the extension function. I believe it was added because there were some cases where instead of conditionally running or calling one or another, it was more convenient to like pass a result. But I'm not sure. But yeah, you can just pass result instead.
All right. So Sergey, if this was the answer you were looking for or not, let us know in the chat. Then there is another question from Juan Wimberg. Can you explain again why after wouldn't be printed if you store a reference to the continuation?
I understand this is the last example. Maybe I will. So there was a continuation unit. Gosh, my fingers are not so used to typing. Right.
Yeah, you rarely do it, right?
So basically, it was something like that. Continuation. Okay. Continuation that resume. Okay. So in the example I showed, this guy was extracted into some function, yeah, or maybe even like that. But that does not make any difference, yeah. So simply when you are suspending, so when you are suspending, you are not suspending a function. You are suspending a function, but also this and also whatever calls that, yeah. So you are suspending this main function. This is probably better, easier to see if I inline it. Okay, so right now you see that the resume happens, in the place that will be reached, that can only be reached if we resume. So it does not make sense. It's like we try to resume when it's impossible to resume. So that's exactly why maybe this inlining function, that's a nice trick to show it, because it's exactly what happens. That's just from the fact that we are extracting function, it does not influence the way how our code works. It could influence how our code works if we would do something like run blocking and launch and stuff. So if I would do it in a separate coroutine, so now I will launch it in a separate coroutine. That's something I haven't talked about yet. It's later in the book, that's why I'm not showing that here. But I am here starting a new coroutine on this launch, and I will start even another one coroutine. Or even not, that actually does not matter. I can just delay the first one. Now the suspension will happen only, will influence only this launch, because this is one coroutine, and I can reach this point and resume this coroutine. So I hope that explains everything. Maybe I should add an example with that.
Well, that was fair enough. Juan just said, the resume is never called. That makes sense. So yeah, I think you touched on that. Then Simon asks, and is hoping it's not off topic, but if you could comment on the relationship between coroutines and threads and how one is better than the other. He would love to hear your explanation.
Yeah, so threads is threads are a system mechanism, and as a concept, they are good, and they are used because multiple threads are needed to run on multiple cores on your processor, because we are on the level of operating system, and that's that needs to happen over there. But there are a few problems with threads. First of all, threads are not cheap. That there are different estimations how much thread costs. Some say it's around 1 megabyte of data. Some says it's about 2 megabytes of data. Nevertheless, making thread costs something. And this is often shown in this old school example of, I have it somewhere in here. Those are examples from the workshop and massive KT. Yeah, so here we have simulation of starting 100,000 threads, making them sleep for a second, and printing a dot. So you'll see that works. But it's super slow. Yeah, in some operating system it would throw out of memory exception, because so many threads, so many megabytes of data, bam, my memory is gone. I am using Mac. I believe that's the reason why it's reusing hard disk, and it's not throwing an exception, but instead it's really slow. It's also a cost of making those threads, keep ending those threads. That's really heavy. Coroutines are not threads. They are very light and cheap. But they are light and cheap for a good reason, not because they are light threads. They are much more than light threads. As I said, a coroutine is just a state yet to be executed. Yeah. So maintaining a thread costs something. If you have a thread, you want to keep it alive, it costs something, not so little. Maintaining a coroutine costs zero. Only the cost of references to other objects, because coroutine is just, the continuation is just an object keeping the local state, references to the local state, and numbers that identify where you finished on each function. So it's exactly like a save of a game. In a game of a save, you keep only data that can be different from game to game. So variables basically state, and the same in here with coroutines. The continuation keeps only data that are needed to resume from this function, and that's it.
Sweet. Love the example, by the way. Just seeing it makes a big difference. Cool. It looks like we are really well on time today. So we have 10 minutes left and there are no further questions. So unless you want to add something, so I don't want to stop you. And Simon says thank you. So it looks like you touched on it.
I think I said everything. I would like to encourage you to stick with me when I will be publishing the next parts of the book. I will explore this topic really in depth. I would like to share most of the content of the book with you, and I hope that I will make a great book. And so I'm working on it, and I think it will be useful for everyone. And also, if you are interested in any kind of workshop, let me know.
Sounds great. If you could send me the link to the book, I will add it to the description, and then future viewers can find it. And besides this, thank you so much for being on, especially on more or less short notice. And yeah, hopefully we can have you back. And the feedback from the chat is also, there are a lot of thank yous coming in. So yeah, really well done. Really liked the chat and the talk. So thank you so much. And for the rest of us, have a nice evening and see you at the latest next month. And if you have any questions, catch up with us on Kotlin Slack. The link is also in the description. Have a good one.
Thank you. Hope to see you again.